Hello to all my friends and to all my enemies on Twitch. It's really good to see everybody here. And I don't know if you've noticed, but I have the chat window open. I have a bunch of stuff just set up to do this live stream. I think doing live streaming has been one of the most complicated things I've ever had to do. And I worked on a bunch of legacy code. So this stuff is complicated. Anyway, so we're just gonna hang out a little bit and talk about unit testing and test-driven development and stuff like that, and I'll show a bit of code as well. Anyway, it's 11 p.m. here in Israel, which is where I'm located. In my spare time, I like to make my own music, right? That's kind of my night job. My day job is doing programming and all the stuff that I love doing with code. So I'm actually coming to you live from my own little studio, which is basically in my basement, in my apartment. So upstairs I have 3 kids, and I think at least 2 of them are asleep right now. And one of them probably will only be asleep probably after I'm going to sleep. I want to do this amazing switch right now, which they only do on TV. Are you ready? Okay, check it out. Ba-bam! That's the way it works. That's how cool I am, right? I'm pretty cool. Manning. Oh yeah, I want to say thank you to Manning. Manning, thank you. Manning has been one of those book publishers that at the beginning you're just saying to yourself, well, book publishers, they just take most of the money, but they let you keep very little of it. But Manning actually does a whole lot more. They actually help a lot with the marketing if you're an author. They're really helpful in helping to set up the structure of the book. And I'm actually writing my my 4th book with them right now. So yeah, Manning has been, I would say, kind of on the forefront of a lot of the publishing stuff that's been done for tech authors. So kudos to Manning and to Cody and to Stefan, wherever you are right now. I miss you. Anyway. So before we start, I don't know if you know this, but if you're stuck at home like me and you have nothing better to do, and you realize that when you come out, when everyone finally comes out to their day jobs, some of us might not actually have day jobs anymore, because a lot of people are being let go. I have a few friends who've been let go as well. And one of the things that's going to happen is that as soon as this stuff clears, this COVID crap clears, a lot of people are going to be searching for new jobs. So every job is going to have a bunch of people fighting over it. So I think now, and I know it's difficult between kids and you're trying to get them homeschooled and all that stuff. It's really, really difficult. But if you have an hour a day to try to learn something, and it's not just to sleep full of depression or to eat late at night. I'm not saying that stuff happens to me. I'm just saying it might happen to you. I'm not speaking from experience, of course. You might want to learn a couple of tips and tricks, a few skills to help you in your next job interview. Things that will help you throughout your work for the coming decade. And I think unit testing and test-driven development is one of those, or a couple of those skills that can be very, very helpful. So first of all, I don't know if you can see, but on the left here, or on my right, I guess. Let's see. Bam. There's a sign that says "Ask Me Anything," but there's also a website called courses.osherove.com. And if you go to that website, I switched to, okay. If you go to this website, I am giving away all of my TDD courses for free, okay? If you enroll in the course, you get TDD in Java, TDD in C#, TDD in Ruby, TDD in Hebrew, TDD in English, Vim, legacy code refactoring, a lot of the stuff that I've been teaching and I've been selling. Some of these are costing, more than $100. I'm actually giving away for free. There are 2 reasons. First of all, I think this is the right thing to do for people who might be losing their jobs, etc. Everyone is kind of strapped for cash. Everyone is afraid of their financial situation. But this is also the time where you can use that time to learn new things. So if you register for these classes, for these courses, you get them for free with no strings attached. Basically, even after COVID-19 has passed, these courses will continue to remain yours. They're streaming and downloadable, whatever you want. If I'm going to create new courses later on, they're going to be for money, but that's probably going to be after COVID. But everything that's currently in the bundle will stay free as long as you register and you get it. So basically, it's like you purchased it, it's going to be yours forever. So definitely do that. So now that I've kind of given you that kind of link, and if you have any questions, I want you to see this big sign over here. It says, Ask Roy anything about unit testing and test-driven development. We're going to spend an hour together, right? Let me just do this. We're going to spend an hour together. I have some coffee here. At least that's what I'm telling you. That's some strong coffee. So if you have any questions about unit testing or TDD that you've always wanted to ask, even if there's stuff that you might have heard from me that you disagree with, the chat is right there. It's right there. Use it. The chat makes this live stream much better. Okay, so the more interactive this is, the better, the more fun we all have. Okay, otherwise, I'm just talking to a wall here, and for that I can just stay at home. Anyway, so TDD JS. I don't know if you've noticed. But I come from a background of mostly C#. No problem. Have fun at the courses. Register. Enjoy. I'm currently writing the 3rd edition of the Art of Unit Testing, and it's all in JavaScript. The previous editions, the 1st and 2nd editions, were in C#. And for this edition, I've decided to do it in JavaScript. No problem. PD more and hardware. I really enjoyed the TDD course on Art of Unit Testing. Surprised that your 3rd version was about JavaScript. Yes, I was kind of surprised too. So let me explain a little bit why I chose to do it in JavaScript. First of all, everyone is using JavaScript. So technically, financially speaking, more possible readers for the book. Second, I really wanted to learn JavaScript in a way that is much deeper than I knew it before. And I know from past experience that the best way to learn something is to teach it. Now, I already know unit testing and test-driven development, and I have a lot of experience with that kind of stuff. I always learn new things, and I figured if I start to do that stuff in JavaScript, I'm going to learn a bunch of other things as well. For example, in JavaScript, this is a multi-paradigm language, which basically means you can do object-oriented, you can do regular modular or regular programming, modular programming, functional programming. And I'm not very good at functional programming, and I'm getting better at this. So for this book, I've chosen to try to do the examples in JavaScript, obviously, but they're going to be in multiple different variations. So for each example that I'm going to do in this book, I've decided, I think it's the first book that's actually going to do this. I'm going to have both object-oriented examples and functional examples, and also modular examples. So when I show stuff like refactoring and dependency injection and all that stuff, because it's JavaScript, I'm going to show how to do it in an object-oriented way, so people coming from C# or Java or C++ would feel like, okay, that makes sense for them. But I'm also going to show it in a functional way as well. So I'm going to have 2 or 3 examples for each exercise, where I basically show a different type of design for the same thing. And that's very, very different from the previous editions of the book, which basically just consisted of object-oriented examples. No problem. Have fun, everybody. Yeah, so that's kind of it. So with examples in C#, that's the 2nd edition. 3rd edition, if you want to head over to this link right over there. The first 3 chapters are already done. and they're in MEEP. They're basically in early access, and I'm currently, and I just gave Manning the 4th chapter, and I'm working on the 5th chapter as well. So the first few chapters are talking about mock objects and stuff like that, and unit testing and test-driven development, and I'm going to talk about this stuff here today. And just as a small mention, I wrote another book with Manning called Elastic Leadership, which is all about leading software teams. The original name for the book was Notes to a Software Team Leader. So if you have any questions about leading teams, you can also use this amazing chat right over there. There? Is it there? Yeah. I'm reading. Yeah. Oh, if you're reading the Elastic Leadership, let me know how it is. I think it's pretty good, but I'm a bit biased. Anyway. Oh, here's a relic from the past. Hey, remember on-site training? That was fun. Yay. So I used to do on-site training. Hey, that sucks anymore. You can't do that. So I'm now giving a shot to do all the online training as well. Which means I've set up this amazing rig where you can change shots like this. Or like this. I'm going to try and give that a try. So let me know if you're ever interested in that type of training. Okay, so what's the agenda for today? I'm going to speak about test-driven development, and I'm going to show all the examples in JavaScript. I'm going to talk about where it fits, where it sometimes makes sense, sometimes it makes less sense. I'm going to show the TDD process. I'm going to explain it a bit more. I'm going to talk about the reasons why I think a lot of it makes sense for a lot of people. And we are going to try to, answer questions live about anything that you have about that kind of stuff. I'm going to show a TDD kata called Password Verifier that I'm using. I've kind of created it for my own training, and I really, really like it. I used to do a kata called String Calculator. String Calculator is great. Password Verifier is a bit more advanced in that the design aspects of it are much more open to interpretation, and I think it gives more challenges in terms of the design that it requires you to do. So we'll cover kind of some of that, and based on your comments, we can do the TDD in a functional manner or an object-oriented. We'll see what happens. So again, let me know if the music is too loud, if the fonts are too small, if my shirt is too black, if my hair is too annoying. Just my nose has had a history of annoying people. So anyway, where were we? I think we were talking about TDD. Anyway, so when we're talking about test-driven development, I want to talk a little bit about where I come from in this world before I jump into a bit of code. Test-driven development is, when I first learned about it, I learned it in the context of extreme programming. So raise your hands in the chat if you know what extreme programming is, right? Just say, yes, I know it, or I have no idea, or just stop making up crap, Roy. So let me know in the chat if you know that term. If you don't know that term, hydrogen oxide. Yes, that's true. Absolutely. ET901. Yeah. Okay. The OG Agile. Oh, that's kind of nice. You know what? I kind of think about that XP or extreme programming. Well, let me just explain for those who are not sure what it is. Extreme programming is one of the first, to me, truly agile methodologies that came about before. It kind of came along, and Scrum came along roughly, I think, in the same time. Scrum won the branding and marketing war. But extreme programming is, to me, the oil that actually makes the engines run. Yes, Bouvet. I used to work in Bouvet. Solve. Hvordan går det? Er du bra? Ja, veldig bra. That was Norwegian. A little bit of a... But so extreme programming does not have certifications and all that crap. Scrum has been an amazing thing for so many consultants over the years. And now there's Safe and all that other beautiful stuff. People are making so much money for that crap. Anyway, Scrum as an idea is not a bad idea. Scrum talks about this kind of concept of, how do agile iterations work and the process and all that stuff. But it doesn't talk about what happens on the day-to-day basis other than some very, very basic things. Extreme programming talks about the day-to-day of working in an agile team, and it describes these 12, I think it's a bit more than, but mostly there are 12 main practices, and some of them include test-driven development, continuous integration. Story points is now less of a, less accepted, but there's a bunch of stuff that comes from extreme programming and people don't even know about it, that it comes from there. And I think that today, if you want to work, in an agile fashion, extreme programming, other than the weird naming, is basically how you're going to have to end up doing it anyway. Because it talks about very, very small increments of work. Scrum talks about these small increments of deliverable value. But how the hell do you implement small increments of deliverable value? And the answer is you do very, very small micro iterations in tests, in test-driven development, and a bunch of that stuff. And these small commits and feature toggles and continuous integration, all these things, they go and they actually make up that cake that you're trying to deliver continuously. So extreme programming is not like free-falling or... But yeah, I agree that extreme programming, the word extreme, it scares managers. Pair programming comes from extreme programming. Isn't that cool? So when I go and consult the companies, right? These days you can't go anywhere, but when I Zoom and consult the companies, or when I Zoom and coach people, pair programming is one of those key things that we like to do. All our desktops face the wall thanks to XP. Yeah, okay. Oh, enter to win a free ebook with your Twitch handle. Hey, I want an ebook. Anyway, so what was I saying? So extreme programming made a lot of the core concept, the core skills that a lot of us want to use anyway. And today we just call it, engineering practices. Extreme programming is a set of engineering practices that allows us to actually become agile. Not become, but just work in an agile fashion. I'm not talking about the big A agile. I'm just talking about, the small a, the one that says, no bullshit, just let me go ahead and do my job. Turn 180 and do instant meetings. Yeah, sure. That's cool. And to me, putting a team in a room that's kind of like a meeting room, where there's like a long meeting table that's round and people are sitting around it, they can pair with each other. To me, that enables a lot of stuff. However, it's not Windows XP. Luckily. It allows us to, do stuff. Let me just backtrack. When we're all sitting in a room, we're doing pair programming and stuff like that, people are going to ask, what about my own little private nook? Where's my privacy, etc.? So it's very important, if you are going to have teams that work this way, especially in COVID. I have no idea what's going to happen now. All these people doing pair programming and stuff with COVID now, what are they going to do? It's just going to be Zoom pairing all the time. And Zoom pairing, I got to say, I've been trying it for the past few weeks. Not so bad. It's actually not so bad because, first of all, you have your own stuff. You can zoom in and out. You can enlarge things. You can do whatever you need to do, and you can even take over the computer. The lag is kind of annoying, but it kind of works. So remote pairing and mobbing is not actually horrible in this new pandemic-ridden, scary monster-based world that we're all living in right now. It's kind of nice. So, and I think that's kind of the beauty of working in these, high-tech industries, is that a lot of us basically can go on, and especially a lot of us that really like staying at home anyway. We're just going to stay home. And if you're like me, just get fatter and fatter and fatter. You know, I was starting to lose weight, and then COVID came along, so I'm not gonna cry about it though. Well, maybe a little. Anyway, what was I saying? Oh, TDD. That's right, TDD. So when does TDD actually make sense? Well, let's see. I've been doing a lot of remote pairing and mobbing, and I've found it helps enforce driver navigator paradigm of programming. Absolutely. But, you know, when I teach people about pairing, I don't even say navigator and driver, because a lot of people, especially if English is not their mother language, mother tongue, you can see that's not my mother tongue, they get really, really confused. So I'll usually just ask people to work together on the problem and switch keyboards every once in a while, and that usually kind of works. But I'll usually ask them to have the person with the least experience on the problem to use the keyboard most of the time. Anyway, so back to TDD, because we're kind of jumping into pairing, which I really like. But let's talk about TDD. So I'll tell you where TDD makes less sense, okay? Because a lot of people think that TDD sucks if they are doing spikes and one-offs. I don't think it sucks, but I think you have to make sure that the code that you're working on is going to live for a while. If the code you're working on is, you're not going to have to maintain it, and nobody else is going to have to maintain it, and you're not going to have to change it, I don't think TDD makes a lot of sense unless you're trying to explore something. You're trying to make sure that you understand how an API or an interface kind of works. But if you're working on something that's going to have to live for a long time, we are going to... I think TDD makes a lot of sense there. If you have code with logic, I think TDD at the unit level works great. I think that if you don't have logic, then ATDD or acceptance test driven development works better for that kind of stuff. And if you're fixing a bug, you know, fixing a bug is actually a lot of fun with TDD. You get a bug notification, you prove that the bug exists with a test. The test is failing because the bug exists. The test is supposed to say, there shouldn't be any bug here, but there is. And then you fix the bug without touching the test, and the test magically becomes green. And that's a lot of fun. Work at Geo Media, and I found it difficult to get time to write any test. Agree with the long-lasting code. Okay. Same experience when I was working for an agency. They weren't really interested in software engineering. That's an interesting... you know what? I've never actually had to work in an ad-related agency, media agency. However, this is really, really important. One of the questions that people keep asking is, oh, how do I even get time to write tests? That is one of the major issues why people don't even write these tests. So let me explain it this way. I don't ask permission to write tests, just like I don't ask permission to do debugging. Because debugging, do you have to ask permission to do debugging from that media agency? And I'm guessing the answer is no. Because it's just the way that you write code. TDD is basically between you and your computer. It's just the way that you write code. Nobody else has to get involved. You don't need anyone else around you doing TDD to do test-driven development. Just like you don't have to ask for permission for debugging stuff, you don't have to ask for permission to write the tests first. It's just the way that you write the code. Do you write the code slower? That's an interesting question. Technically, you are writing the code slower, but it's very likely that if your code is somewhere on the left of this list over there, you're actually going to release faster. And if we have time, I'll show some numbers from stuff. Let's see. But if those tests aren't run continuously, they will bit roll. Yeah. Okay. So if I'm the only one writing tests in my team, then I will set up my own little CI server that runs the tests all the time, and that way I make sure they're maintained. And that stuff saves me. And I've had a few teams where I actually had to implement that kind of stuff, where I was working in my own little bubble, because that's the way I had to work. And if people didn't like the way I was working, well, tough crap. But I could find a different place that would admire these types of capabilities. And remember, the idea is that you're not just going slower, you're actually going faster by going slower. So if we're talking about how long it takes to write tests can take 100% more, especially if you don't have a lot of experience. Sometimes even 200 and 300%. Your desk sound set looks incredible. Cheers. Yeah, thank you. Yeah, as I explained, it's in my studio. By the way, can you tell I have ADHD? Because I think I saw a squirrel. What was I saying? Time to write tests. Time to write tests. Boy, Martin Fowler, such a smart guy. Yeah, refactoring is part of the job too. I don't ask permission to do refactoring. I don't ask permission to do debugging. It's the same thing. However, yes, it will make you slower to write the code, but it will not make you slower to release the code. That's the main difference. At the bottom line, the time that you take to implement writing the code initially is saved usually many times over during the process of the release, which might have a lot of debugging and manual testing and a lot of other stuff, bug fixing for code that wasn't tested and all that. A lot of that stuff goes away or reduced in in crazy amounts because we take the time to build the quality in as we write the code. So it's really important. There's the first line, which is, hey, it takes me double time to write the same amount of code, sometimes even more. But the bottom line is it might actually take me the same amount of time or even faster to release the code over time. But nobody usually takes the time to measure or do experiments with that kind of stuff, because are you just going to do experiments with teams of 6 months of 50 people teams, one with and one without TDD? It's pretty expensive to do those experiments. Yeah, Working Effectively with Legacy Code is a great book. Anyway, now it's really important when people talk about test-driven development. Let me just see if you can make this bigger. Check it out. Pa-pam! Yeah. Working Effectively with Legacy Code. Why am I saying that? I'm talking about types of tests and levels of tests. So this is an important question to consider. When I'm writing tests in TDD, at what level am I writing the test? Obviously, I come from the unit testing world, so I'm really comfortable writing the stuff here in the lower level. Unit tests and component tests run in memory, but then we have integration tests, which basically run in memory, but they might have real dependencies. Okay, they might actually use maybe an in-memory database. And then we have API tests that are out of process. So I might invoke an API of something which is not in the same process as my tests, or maybe saved to a database, etc. And then at the top we have end-to-end tests. And end-to-end tests, they're supposed to bring the most confidence. Technically, if I were able to write end-to-end tests to all of my system, maybe I do it, but the problem is that the cost of end-to-end tests is so big. Just the maintenance of them and the fact that they make so much noise when they fail, it really creates a big barrier for a lot of people. So a lot of teams, when they start writing these tests, they start writing them in anger. They're like, okay, we're gonna bring in a whole automation team, and they're gonna do all these types of stuff. And that automation team creates this huge unmaintainable suite of tests that nobody understands. And when they fail, only 1 or 2 people in the company know why it failed. So then they have their own little dashboard and their own little build system. And I call them the build whisperers, because when the build is red, you have to go and call these people and ask, hey, is the build really red? And then those people come into and they listen to the system, and they're like the horse whisperers. They're like, yeah, it's actually not red. It's actually green, but it doesn't tell you it's green, but I'm telling you it's green. So these people then become the bottleneck in the company. So end-to-end tests, they present a lot of challenges, but does that mean that we can actually get rid of end-to-end tests? And the answer is absolutely no, we cannot get rid of them. Because what if we only wrote unit tests at the system level, for all our systems? Technically, we would have really fast running tests, but we wouldn't actually have a lot of confidence that the system actually works. We would still need to, we would want to test things at a high level, at least a little bit, to make sure that the glue between all these components and systems and APIs and configuration is actually working. So should we only write tests at the top level or the bottom level? And of course, a lot of what I would recommend is that you have a combination of these things. So when I encounter a system, when I start thinking about what is my testing strategy for a system, right? And I think about at which level am I going to write something, I usually ask myself, can I get away with writing just unit tests for that stuff? And if there's something that I wouldn't feel comfortable just having a unit test, because there's something that cannot be tested at the unit test level, then I'll write an integration or an API or maybe an end-to-end test. So I might have one happy scenario at the end-to-end test level, but then that happy scenario could represent or trickle down for all its variations at lower levels. So I might test a login successfully at an end-to-end, but then how do I test invalid logins, and how do I test bad tokens and all that stuff? I could test them at API levels and component and unit maybe, because it's much easier to simulate, it's much easier to test, it's much easier to write those tests. I don't need to write all of these scenarios at the end-to-end level. There's absolutely no reason, because the amount of confidence I'm going to get for the first end-to-end test is going to be huge, but the second end-to-end test is going to be just slightly different than the first one. So I'm not going to get a lot of extra confidence from it, but I'm going to have to pay all of the maintenance costs and the fact that it runs very, very slow. So then all of my, if I just stay at the end-to-end level, then my builds take 4 hours. I don't want that. But I can't get away without end-to-end. So I'm going to have a few. And my rule of thumb is 1 to 5 or 1 to 10. One end-to-end test, and then 5 or 10 lower level scenarios for the same kind of thing, or the other way around. So that's kind of the basic thinking about it. So if we're talking about TDD versus ATDD, TDD to me is a lower level, test-driven development. And then when we're talking about integration tests, we're talking about acceptance-based test-driven development. So I might, as a user, I might write a test that proves that I can load up a screen or something like that. And that test at the high level might fail for maybe 2 or 3 weeks, or maybe just a week, before everything at the bottom works and trickles up until that test finally actually works. So that's the way I think about that kind of stuff. Anyway, so that was kind of a little bit about like levels of tests. Let's talk about skills. What skills are required for test-driven development? Let me just make sure everything is working okay. And let me know in the chat if something is not working, or if I'm stuck or something like that, because I have a monitor up here and it shows weird stuff going on. Okay, looks like everything is okay. Okay, so when I talk about TDD, I think there are 3 main skills that are required. And again, if you have any questions about the stuff I'm talking about, write them in the chat and I'll answer them. So being successful in test-driven development requires you to know how to write good tests. You can write really crappy tests first, right? The skill of writing a good test is different from the skill of writing the test first. And then we have design skill. So even if you write test first, it's not going to save you if you don't have the ability to design code well. And that's a separate skill. That's something that we have to learn, something that we have to constantly practice to understand how it works and how it's supposed to work, how our APIs are supposed to be look and behave. And I think the only way to learn that stuff is just through slow practice. So if you're wondering why a lot of people and companies are really struggling learning test-driven development, I think it's because a lot of them are trying to learn all of these things at the same time. And I think if you're trying to learn all of them at the same time, you're going to have a hard time. You're going to have a really, really hard time. I think there are very few people in the world that can jump into TDD and it just works and there are no kind of added questions. Because one of these things is gonna be difficult, at least, if not 2 or 3. Okay. So today I'm mostly going to talk about writing things test first. I was told to write tests fast without even thinking about the test names. Just stumble ahead until you get some functionality fully working. Interesting. So that would be an example of the skill of writing test first. But is it a good test? That's a different skill. So maybe that's a good way. Maybe that's a good way to separate it. However, I will say that there are some things that we can include even as we're learning to test first that are very easy. For example, naming conventions for tests and stuff like that. I'm seeing a bunch of question marks. I don't know what that means. So I have a bunch of exclamation marks to you. Great questions. Test-driven development. Make it fail, make it pass, refactor. So when we're doing TDD, when people talk about TDD, they basically say, oh, it's just very easy. There are 3 main steps. You make it fail. You don't write a line of functionality without a failing test. And then make it pass. You don't touch the test. You make the test pass without touching them in the simplest way possible. So think of yourself as the world's laziest developer, or an intern who just came into work and has never really written production code before. How would they solve it in a very simplistic way? And then refactor once we have tests actually passing. That's all good and well. But I like to take this thing and kind of break it down a little bit. So when I, in response to write tests without even thinking about test name, I start with what behavior I want in the system and express that as the test name. Yeah, that's cool. However, be aware there are many ways to learn skills. So the fact that one person does not focus on the names and another person does, I think that's fair. When I'm teaching, I do focus on the names because I find that the names actually help me teach. The names actually help me teach because if you can come up with a good name, then you're actually starting to design your test. The name will tell you what you're trying to test. We'll talk about that when you actually write some code. Anyway, when I start in TDD, the first thing I do is I write a test to prove the next small piece of functionality is missing or wrong. Okay, so it doesn't have to be big. Just one small thing that's missing. One small thing that isn't working. Because I'm going to do this a lot. There's going to be a loop that goes very, very quickly. And then I run all the tests. And of course, maybe at the beginning, the test won't even be able to run because the code doesn't even exist. So I'll make sure the code exists, and then I run the test. But I don't actually implement the missing functionality. I want to see the test fail. So, my first question for the people in the chat who actually made it their business to come in today and listen to this stuff. Why do I want to start with a failing test? What are the reasons that you think make sense? Why do we start with a failing test in TDD? Take your time. I'm here all day, at least for the next few minutes, 20 minutes, 30 minutes, whatever it takes, 1,500 minutes. Why do we start with a failing test? Oh, people. To make sure it's not implemented yet? Sure, yeah, that's a good reason. To prove a test is passing for the right reasons. Ooh, I like that one. Well, 2 points to John. There's another reason. So you can prove the testing system is working. You have a successful system. Well, Kinda, yes, exactly. I want to start with a failing test because I want to see that my test is failing when it should, and later I want to see that it passes when it should. So by doing this, I'm actually testing my test. So I don't know a lot of good ways to test your tests. I mean, are you going to write tests for your tests? How do you know that the tests for your tests are actually working? Yeah, you're going to write a test for the test for your tests? It's kind of weird. My point is, you know, there's this thing. What's the name of that practice? Where you actually, there's code that it changes. I forgot the name of it. Yeah, mutation testing, exactly. So mutation testing tries to do some of that stuff. Mutation testing tools, which today I don't think are still good enough, try to go to the code and then break something and then run all the tests related to that piece of code, and at least one of them should break. And then that way they know that code actually makes sense. Polymorphism. Polymorphism, that's good. Well, polymorphism is always a good answer. I mean, if my wife asks me why I didn't take out the garbage, I just shout polymorphism. That usually breaks the argument very, very quickly. Anyway, what was I saying? Oh yeah, we write a test to prove the next small piece of functionality is missing or wrong, and then we're making sure the test is actually failing because we want to test the test. By the way, it also makes sure, like someone wrote here, we want to prove that we understand what it is we're testing, that we're testing the right thing. Because what if we start with a test and it's not failing? Either we forgot to maybe assert something, or we're actually testing the wrong part of the system or a wrong functionality. And then we implement the simplest possible production code to make all of the tests pass. So I run all the tests again, and that's good. And they should all be passing. And then I incrementally do refactoring. So I'll make one small change and I'll run all the tests. And then I'll do another small change and I'll run all the tests. So I might rename a function. I might extract a variable. I might take a line and extract it into a separate function. I might extract an interface maybe. I might do whatever it is I need to do, but I don't do 5 steps at once. I do one step and I run all the tests. And I do another and I run all the tests. And this is kind of a small loop inside the big loop. And the reason if code passed it first, it could be that we covered just too much ground. Yeah, that's true. Yes, it could be if my test is passing, that it might be that I implemented the code already in a way that I implemented too much functionality. Absolutely, that's one good way to think about it. But that is not the main reason that I use the failing test as a tool in my work. But it is a flag. It could be a small flag, absolutely. Or a big flag, depending on what I'm trying to teach. Let me know in the chat if the music is annoying or not. Anyway, we run the test and we do this loop, kind of very... Sometimes it can take 5 seconds, 10 seconds. And we might have 10 refactorings. And then we go back to the beginning. And then we implement the next piece of small functionality. And that's the loop. So if we're thinking about this loop, we have 2 main loops here. And each one of them has a different purpose. The big loop is about creating code that we trust. And then the small loop is about creating code that we like. Okay, so if we just do the big loop, we're going to have code that works. If we do the small loop, we have code that's maintainable and that we like, that we're proud of. That's why the refactoring part is so important. What do you think about people who measure loops or iterations per day as productivity measure? Every time I see someone measuring a number, I treat it as what I call a leading indicator. A leading indicator is very different than what is a lagging indicator. So what is a leading indicator? A leading indicator is a metric that can be usually easily gained, but assuming that the metric is true, we should be on our way to changing a lagging indicator. So what's a lagging indicator? For example, how many times we ship a year, how many bugs we find in production. So a lagging indicator is a metric that it's very hard to game it. It's very hard to cheat. So a leading indicator would be coverage. Sure, I can get you 10% code coverage tomorrow. But it's not a lagging indicator. Coverage is not a lagging indicator. You know what is a lagging indicator? Confidence. Confidence is something that I feel. And if I measure my confidence over time from 1 to 5, I can say that my confidence is either higher or lower in the code. And it's based on many, many different things. Lagging indicators. So actually there is a talk that I did, and I recommend that you go and watch if you're interested. It's called Lies, Damned Lies, and Metrics, that talks specifically about this kind of stuff. So Google that and learn the difference between leading indicators and lagging indicators. So a leading indicator, again, would be the amount of tests that I have. Sure. A lagging indicator would be escape bugs in production. One of them is supposed to influence the other. One of them is very difficult to cheat, but very easy to measure. The other is very easy to cheat and sometimes very difficult to measure. But we need both of them. One of them gives us kind of a sense of what we think might happen, and the other tells us whether we did the right things, but it's already too late by the time we find out. So we have to use both of them. Hopefully that answers the question. So I don't like people measuring loops, but I will look at, as an indicator, as a leading indicator, how many times the build ran per day. Or because it tells me how many commits were actually merged into the branch. And if the build hasn't run for 2 days, I'm guessing people are either afraid to commit, or there's a different reason why people are not merging, or maybe there's a bottleneck in the pull request queue or whatever. So it's not that the build running is my key indicator. It is something that tells me that I might influence something bigger if I don't do it. But God forbid that you only measure leading indicators and not lagging indicators, because then you have organizations, and I've seen them, and they exist today, and I'm sure in the chat a lot of people will agree, that only measure leading indicators. So if your project manager comes to you and asks about the coverage, you know that basically that metric is so easy to cheat and game that it doesn't really matter. Coverage is not the same as confidence. It is not the same as quality. Anyway, we can talk about this all night. So we have code that we trust and we have code that we like. Now let's talk about design, because I said that we have the skill of design. So where does design happen in TDD? It happens in 2 places here. It happens at the beginning there, when we are just writing the test first. We're designing the API of our function. We're designing the public signature of the API that we're trying to create. So we're talking about usability and how easy it is and what parameters and what dependencies we have and all that good stuff. But then we also have designed as we're refactoring the code after the test is passing, and that refactoring usually happens at a lower level. So it happens under the public API. So that's an internal refactoring of the guts of the system. And that refactoring, again, is internal design, but it is not external facing design. So 2 different types of design. Now, if we're going to learn TDD, I recommend TDD katas. So has any one of you here in the chat ever done any kind of martial arts? Judo, karate, ninjutsu, aikido, and a bunch of other stuff? And if yes, cool. And if no, not cool. But the idea is that when we're taught, nice. Now I'm just thinking about Taekwondo. That's how good my ADHD is. Anyway, katas are basically a way for us to continuously measure ourselves in a way that allows us to make small adjustments as we repeat the same exercise over and over. Sometimes, for example, We'll work just on our breathing as we do the kata over and over. Sometimes it's basically a physical exercise that we do that gives us several benefits. First of all, it gives us the ability to create muscle memory, right? Muscle memory, so that the actions that right now we have to think about become automatic. So they become automatic, just like this. Ha, ha, ha. So we don't have to think about them when the time comes and we have to battle someone for their mouse. But the second thing is that we can use these katas to slowly learn something slowly practice. And I think the practice of these katas in software is a beneficial idea. String calculator is a good way to practice test-driven development. So if you want to practice TDD, you take one of these katas that we can see here, and you decide that you're going to try and do that in the at least once a day for 20 minutes. And repeat the same kata at least a couple of weeks, if not more. And the idea is that you might repeat the same exercise, but the solutions might change. Or not the solutions, but the way that you approach the problem might change, that you think about the problem. Maybe your design sense changes. Maybe it just becomes easier and easier to write the test first. And that's good enough, because for each time we repeat the kata, we can decide. You might be getting dropped frames because internet in Israel is crap. But if you're the only one, then your internet is crap. Either way, I can't control it. Let's see. So the kata we're actually going to do is called password verifier. So what is the password verifier? Let's see if I have the example here. Let me just put that here. So if you want an example of this kata, let me just close this. On my website here. Oh yeah, it's very laggy. Internet in Israel sucks. There's so many corruption and monopolies, but we're not going to talk about politics. If you want to get the URL for this, you can look at this URL. But it's basically a very simple kind of thing. We are adding verifications to our function or class. So imagine you're writing a password verifier and you want to make sure, let me just disable this for a second. And you want to make sure that, password lives up to these basic sets of rules. So far, so good. So if we wanted to write this kata, we wanted to implement it. I'm going to open WebStorm because WebStorm is great for JavaScript, but you can use VS Code or whatever it is you want. And in this case, I'm going to use Jest because Jest is the framework that I'm using for it's Roy Social. Oh, yeah. In the panels below, yeah. Okay, that's cool. Thanks, Manning Coda. Anyway, so right now I just want to make sure everyone can see. Are you able to read the code easily, or is it too big or too small? Please let me know in the chat. Maybe I'll make it a bit bigger. I like it. I said, is it too big or too small? And you said yes. So I'm going to use Jest, and but it doesn't really matter. Kind of small, that's what she said. Okay. So, does it matter if we're using Jasmine or Jest? The answer is no. Because all the patterns I'm going to show have nothing to do with the framework we're working in. Let's see. Is it better? So I can start with a simple test that I usually start with a describe somewhere, and the describe will describe the entry point or the feature that I'm trying to test. So the first thing that I usually try to do when we're talking about naming, if I say naming, I try to do these three pieces of information. The entry point or the feature name. So the entry point to the API I'm testing or the feature name that I'm testing. I want to explain the scenario. Scenario. So under which conditions and the expected behavior. So all these three pieces of information are really, really important when we're talking about test naming. If we remove one of them, then it forces the reader of the tests to read the code of the test to understand what's going on. And if at all possible, I usually make sure, my rule of thumb is assume that the reader of the test is a serial killer that knows where you live. Don't make them ask you any unnecessary questions. If they have to read the test, they get annoyed, they come to you asking questions. So verify pass could, in this case, could be the entry point. I could then use a nested describe to do the scenario. Hi. So what is the scenario for verify password? So I put in a bunch of examples here of rules that we could implement, right? These are some of the rules that we can see here. Password should be larger than 8 characters, etc. We have a bunch of rules. But the way I think about it, these rules represent different entities. So technically, I can have no rules being configured for this system and still be able to do my job. So if I'm trying to implement this system, the first thing we have to realize is that code doesn't even exist. So if I'm trying to write this code, I'm writing a test that forces me to write that code. So the test is basically my canvas. The test describes how I would like to have code being written. I hope that makes sense. So I can say, what is the simplest scenario I can think of for verify password? And the scenario I can think of is no rules. With no rules configured. And then I can use an it. I can say it, well, in this case, the expected behavior is always passes. So this would be one example of how I can use kind of the nesting to describe all three parts. Now, this is just one way to think about it. Technically, I could do something like this. Maybe I don't even need to describe. I can use just, and I can do a test like this and say, verify pass with no rules always passes. And as far as I'm concerned, this test is pretty much the same as the other test, but it might actually be a bit more readable because there is less nesting going on. It seems less complicated, but it contains all the information that I need to understand what's going on. When the test fails, the name of the test is what I see in the build log. I don't see the comments and I don't see a lot of other things. So I'll leave it up to you, but what I'm saying is no matter what is your mode of transport for writing these tests, the three pieces of information are really, really important. If I take over, let's say I don't have this one, right? If I remove one of these things, for example, hey, you won a free book. Congratulations. Would look as if a single line is CDD oriented, nested one is BDD oriented. Oh, that's a different, that's a really interesting box of arguments that we can open. What is BDD? And when people say BDD style, usually they mean something that kind of looks like this. really it's just wording. The information is the same information. That's why I really don't like talking in these terms. But when I was talking to Dan North in one of the conferences, when people could still go to conferences, and he's basically I believe he's the originator of the name behavior-driven development. He said that it's about working with people. It's about working with the non-technical people, working with the customer. So behavior-driven development is basically about having conversations with the customer. It's not about how your API looks in the tests. Yes, the API can help because it's a cucumber-related stuff, like the give and when then, but the fact that we have nested describes and its is not the thing that makes it BDD. It is the talking to the customer that makes it BDD. I hope that makes sense. At least that's the way I understand it. Could obviously be wrong, and we're always wrong in this profession. In fact, I would argue that if anyone tells you absolutely without fail that this is the exact truth of something, then they don't realize that it could be wrong as well. So, BDD black box, TDD white box. Well, I would say black box is more of an ATDD, acceptance test driven development, where you would test things at a higher level. And these are just different APIs for the same damn thing. Both of them can be either white box or black box. So I don't like to, when we say black box or white box, in my head, white box means I know what's going on under the covers, and black box means I have no idea what's going on under the covers. When I design my tests, even unit tests, I try to keep my tests sort of black box-ish, in that they don't know, so that we can refactor the internals later. But they're still unit tests, which means they're pretty much white box, as far as I'm concerned. But there are just levels. There's a 50 shades of gray in that stuff. Anyway, this is about naming. So as far as I'm concerned, this is a good name to start with. So does it matter which one I'm using? And usually, the only time where I feel like this one is preferable for myself, for my own self, and for your team, it doesn't matter which one you choose as long as you're consistent, is that I might use, I know I just said consistent, but I'm going to tell you that you can use a combination of these two styles. Okay, so I'm not even consistent in telling you to be consistent. So I'll use nested describes. Usually I'll put this type of test. I'll still put a describe on it, like this. And I'll say password verification or something like that. And I'll put it right there. And then I'll put a bunch of tests in there, because I like to kind of at least box things in a way, not white box or black box, but when I'll use nested describes, I'll use them when one scenario with the same entry point can have multiple results. So for example, if I could write verify pass with no rules configured, always passes, but also does something else. For example, it always passes, and it writes to a log file, to a logger. You know what? Calls a logger. Luger! With no rules message. Right? So in this case, yes, this is JetBrains ID. I really like it. I like the refactorings that I get from WebStorm. I like it better than VS Code, even though VS Code is really, really nice. But I wanted you to notice, in this case, the nested describe is giving me the ability to describe two outcomes for the same action. right? Or two outcomes for the same scenario, but they're going to be in different tests. Every it is a test. What does that mean? If one of them fails, the other one still executes. Technically, you have ways of doing things that don't fail, even if you have multiple asserts in them, but the readability factor is also very important. So now I can say that verify path with no rules configured has two behaviors, two external behaviors. If I wanted to do it here, I would have to do another test and repeat some of it. So sometimes I'll use nested describes when I have multiple expectations from the same behavior. Yeah, it's a good solution. Again, to me, it's not a solution to the problem of multiple asserts. It's a solution to the problem of describing multiple behaviors. Yes, and I don't like repeating myself, but even if I were doing the same test, let's say that I was doing complicated stuff here, right? And then I would do my assert in there, like to create something. And then I would do the same test with no rules, and I would say calls logger. That's kind of weird, right? So what I would do is I would say call creation function, and I would extract this code here. So there wouldn't be like these 5 lines of code here. I would do the refactoring, and I would still remove kind of these duplications from the test, so maintainability won't be an issue. Here, it just lends itself to that kind of situation, so that's where I would use it. Okay, so that's one way to think about it. I'm going to use this for now, because most of the time what we're going to do is we're just going to use one. You know, I'll just keep it here for later. By the way, let's run these tests, because right now the test is running. I'm going to use Wallaby. If you don't know Wallaby, and I'm not associated with them, but I did ask them for a free license because I really like the product. Wallaby is like what NCrunch is for C#. So it's a continuous testing tool and it runs in all the IDEs. And I really like it because it does stuff like this. If I run it, it gives me real-time feedback of the status of my tests. So I can see coverage, which of course, remember, you shouldn't care about coverage, but it makes it easier to work with my tests later on. Okay, so okay, let's see. No. Okay, so right now, just so you can see what happens if I do expect true to be false. You can see that I don't even actually have to save the code, and I can see that my code is failing. This is a message from Wallaby. And I can see here at the bottom, 1 failing test, 2 passing. And these are the 2 that are passing. So let me actually get rid of them, just creating extra noise. Can we all agree, while you're here, that you should definitely register for my Twitch channel? You know I have my own Twitch channel, right? It's right here. I just started in Twitch just a few weeks ago, so I'm still new at this stuff. But I'm hoping to build a following and a bunch of people that are listening to my every word live as I say it. It's more of an ego thing, really. So anyway. Okay, so what am I trying to do? Remember, I'm trying to do TDD. I want to do the verify pass. So I'm going to write the test as if the code already works. So let's do that. I'm going to use the function as if it already exists. Thanks. Follow. Hey, follow and subscribe and click on the link and smash up the like and all that stuff. How do you do, fellow kids, right? That's kind of the way it works. So what if I do a const result? Roy, just write some damn code. Const result equals verify pass. And again, this is a function that doesn't exist yet. And now, look at this. I get to decide, because the function doesn't exist, I get to decide what parameters it gets. Let's see. So this is where the design stuff comes in. Remember, I told you that design happens. This is where design happens as well. I could decide that the rules is just an array that I send in. There's no rules, because I said there's no rules right in the name of the test. And so give me a hand with that. That'd be great. Thank you. Yes, I need people to know that I exist on Twitch. Yeah. Anyway, verify pass. This is the thing. So, and then I can say verify pass and now actually give it a password. So actually I have a question for the people in the chat. What should I put in this parameter? What string should I send in to verify a password with no rules? And I know that there's a lag between the time that you type, and that's okay. You'll just have to be patient with me. Empty. Like the word empty, or just an empty string? Because empty looks weird sometimes. So we don't want magic strings. For example, false. Oh my God. If I write false, this is, to me, like a magic variable. This is a magic variable. And the reason is because that serial killer is going to look at my test and say, verify pass. But why did you send in a false string? Is that something that are you going to try to parse that false? Let me go to their house and ask them. And I'll just bring this handy knife with me. Oh, any password. So this is my inclination, is just say any string or any pass. Any string is usually okay for me, but any pass would work as well. No. Okay. So now this function doesn't exist yet. I'm not gonna write that function. I'm gonna finish my test first. This is how I like to do TDD, okay? I'm gonna finish my test first, and then if I like it, then I implement the API. If I don't like it, I'll change the API, and there's gonna be zero cost to my design changes right now because the code doesn't even exist. Expect result to be, anyone know? If I'm not sure, and this actually happens a lot to people who are new to unit testing or TDD, they're kind of getting confused with all these asserts and whatever. Look at the name of the test. The name of the test should tell you what it is you're trying to do. And I think good names for tests are like roadmaps. There are maps that tell us how we're supposed to be. You know, what were we trying to do? What did we mean to do when we're doing all that stuff? Okay, so I'm gonna say it has to be true. Now, this test is failing. Remember, it's failing because verified pass doesn't exist yet. So I'm gonna make it run, but still fail. So I'm gonna do this. Const, and in this case, I'm just gonna do the function right here. You know what? Actually, before I do the function, let's talk about the design a little bit. Maybe I come from a more functional background, and I don't like the fact that I always have to call verify pass like this. Maybe I want to use currying or something like that. Test naming to prevent paralysis. I should start with the assert to get an idea of what I want to test. Sure, whatever works. We're not judging you. You're judging you. We're all in a learning safe environment here. Don't worry about it. We love you, and it's gonna be okay. It's gonna be okay. Anyway, let's talk about design. So let's say that I didn't like this design. Maybe I wanted a more object-oriented design because I come from a more object-oriented world, and in this company, this project, everyone likes to work in an object-oriented fashion. So what does that mean for me? Maybe I can do something like this. Const verifier equals new password verifier, and I'm gonna send the rules like this. Maybe I like this type of stuff, and then I'll call verifier.verifyPass. Notice that I'm doing this design before the code actually exists. I can kind of try it out and see what it's like to be a user of this design. Maybe I don't want to do object-oriented. Maybe I want to do a more functional with curring. So I can say verifier equals make verifier that takes the rules, but it's just a function. And then the function looks like this. So now I have a function that returns a function that's already pre-configured. Verifier. Yeah, so you can see the design was, if I didn't have these notions of design, the fact that I'm doing test-driven development wouldn't have helped me if I didn't even know what it is that I'm trying to achieve. Verifier. So it looks like this. Either way, I have to decide on one of them. 7 stages of naming, 7 stages of hell. By the way, I don't know what is Arlo's seven stages of naming, so why don't you put a link to that here so that I can learn more about this? That sounds interesting. Verifier. So let's say that I still want to just call it verifier. And I'll put the rules here because I want to make things simpler for our demo here. Okay? So in this case, I can say verify pass. And then I can go ahead and actually create the function. Const verify pass equals something that takes the rules. And it takes the input. And then it does something. Thanks for the link. Let's start. Let's see if we can click this. Let's see. Did it open it here? Okay. Okay. Naming a process. Naming as a process. Deciding the things the code should do. Deciding which things go together. Deciding which abstractions. Picking a name. Picking. Trying the side effects. Keeping your name out of it. Oh yeah. Okay. Interesting. Interesting. I never thought about naming as a process because TDD. Maybe it's a good. That's a good point. Maybe I can include a link to that maybe in the book as well. It's a good point. Thanks for that. Anyway, so we have the verify pass. Now remember, the first rule of TDD, we want a failing test. We would like a failing test. If we want a failing test, maybe that's a bit, maybe now my voice is not as loud. If we want a failing test, we cannot just return true here. We have to actually make it feel like a bug. Oh god, this music. So what I can do now is I can say return false. Now, why am I returning false? First of all, I want to see that my test is failing when it should. Remember, now we're in stage 1 of TDD. So I can see expected true received false, and that's cool. Now I get to make the test pass in the simplest way possible. And you're going to hate the way I'm going to do it right now, because remember I told you to implement things in the simplest way possible. Could be very naive as well. What if I just do something like this? Return true. And immediately you can see that everything is becoming green and my test is passing. Now, if you're looking at this, some of you might be puking in your mouth right now. And I fully understand. Would any one of us write this type of code for a living that does so little for the purpose of that test? And to me, this is, where things become a bit more difficult, because yes, that's actually how I usually recommend continuing, because this returning true now is code that technically I would never write myself. I would never write this code. However, if I wanted to fix this code, I can't. I cannot change the functionality of this code because I don't have a failing test. Okay? And if I don't have a failing test, it means that technically my functionality is read-only. So if I want to change this code that I know is crappy, I have to prove that it's crappy with a test. So I can go ahead and say, you know what, this is not good enough. So let me write a new test that proves it's not good enough. Okay, verify pass with... So which test is going to prove that this code is not good enough? It has to be a test that proves that the code sometimes has to return false. And of course it's going to fail. Okay, so I'm going to write now a test that forces me to add new functionality. So verify pass with a failing rule returns false. Actually, maybe not returns false, maybe fails. I think that's more... Okay, so now I can go ahead and say const rules. It's just an array. And there's just one rule in the array, and this is where I get to design how rules look. And in my head, a rule is just a function that takes an input and returns a boolean. So in this case, it's an always failing rule, so it always returns false. Now, yes, technically I can get rid of this input, but I'm not going to get rid of it because I think it makes things more readable. In fact, I could put this whole thing here like this, maybe. And now I can say const result equals verify pass with rules. In fact, let's call it one failing rule. Let's call it like this. And again, any input one failing rule. One failing rule. And again, if you have questions in the chat, let me know about what the hell's going on. And this music is annoying. Okay, so I have a verify pass, one failing rule, any input. And if I'm not sure what to assert against, I'm just going to look at the name of the test. Oh, it fails. Okay, so expect result to be false. And at this point, I can go here and say, okay, you can see that now I have, if I click here, I can see I have one test failing. It's this test right here. This test is still passing. So now I get the chance to get all of these tests passing in the simplest way possible. So any recommendations of what I could do? One thing we could do is, for example, if rules length is bigger than 0, return. And again, this is a horrible way of implementing it. Return false. You'll hate me. Now, again, this is a horrible way of implementing it, and I would never, ever, ever write code like this. Except when I do, and then I have to fix it. Unfortunately, now, all of the tests are passing. By the way, if you're wondering why something here is orange, I think it's because of the length, but I'm not sure. I'm not sure why it's orange. I think usually it's because the orange is like this line took a longer time, but I'm not sure. On average. So now if I want to say you can't always return false if you have a failing rule, then what can I do? I can actually prove that you can't just always return false. Sometimes you actually have to return true if you have rules, right? So again, I can go ahead here and say, okay, let's do another test. Verify pass with a passing rule passes. Right? Notice how I'm going like X, no Y, no Z, no G. Well, like every time it's like my right brain and my left brain are fighting. So I can say now const one passing rule is just an array, and that array has a rule that takes an input and always returns true. And then we'll do it const result equals verify pass with one passing rule and any input. Expect result to be true. And of course this is failing. Why am I adding these tests at the top? In this case, I'm adding them at the top just because it's easier. But sometimes I'll then later just change their order so that the reader of my code as my test can see the logical path that I followed by implementing the code. So sometimes I'll do it for readability. In this case, it's just for the demo. Okay, so now what can I do? If rules length. Now I actually have to do something, right? What if I just do the simplest thing could possibly work? Remember, I'm just talking about, I can always assume there's just one rule. And why can I assume that? Because I don't have any other tests that have more than one rule. So I can just do rules, and then the 0, and it's just a function, right? Hey, I don't even have to pass the input. Isn't that cool? Technically, I can do it like this. I can do input. But I know that that rule doesn't actually check the input. Cheers. So technically, if I don't use the input, it will force me to write another test that proves that I should be calling it with the input. Right? And that's kind of the idea. So you can see this back and forth is happening. Now, again, the code becomes more and more generic. Okay? That's kind of the idea. When we implement the code, we start with code that is very, very specific. It will only answer to a certain scenario and then only to a couple of scenarios. And then each test that we do is kind of like peeling the layers from an onion. And each layer is forcing the code under test to become more and more generic. So now I can go and say, well, technically, yeah, but now I have two choices. Either I can prove that the input has to be used, or I can choose to say, but what if you have more than one rule? So I'll leave that up to you when you do your own katas, but I can say test verify pass with one passing and one failing rule. What should it do? Well, what we want to prove here is that it actually loops over all the rules, right? So technically it should be failing. because whenever it has a failing rule, it should fail. So now if I say const rules is just an array, and the array has one rule that is an input and returns a true, because if I did a false here, my test would pass already. Because by default, I always execute the first rule. So I'm going to do the failing as the second rule. So let's do another rule here and say input, and this one's going to be false, dude. Okay, const result equals verify pass rules, and again, any input. Remember, the input is not the important part here. Expect result to be false. And it's true. It's true that it's not false. And again, what this proves, by the way, I want you to see how cool this is. You see that we have a green and red, and we have a gray here. You got to see the gray here. What does that gray tell me? This code was never executed. This line was executed. Isn't that cool? Again, coverage is not the important stuff here, but there's an indication that I'm not crazy. So now this line is failing on one test. So now I can go ahead and actually start running over all of the tests. So I can say const failed is, let's say, rules. Let's do a map, and for each rule, which is basically a rule in our collection, we are executing that rule. Remember, we're not using inputs yet, and we're mapping it into a Boolean, right? And then for that, we're just going to do a filter for everything that is false. So result is false. So what does this line give us? It gives first it runs all the rules, and it gives us a collection with just the amount, with only the failed rules. So now all I have to do is to say return failed length is 0. Does that make sense? You should check font ligatures in WebStorm to be seen as this. I kind of like this. I don't know. I'm kind of used to this arrow looking like this. I always feel like these arrows, they begin to, I don't know, they look alien at some point, especially for people who are not used to it. But by the way, that's also the reason, I don't know if you've noticed, that in my configuration of WebStorm, I don't have any hints inlined. Like when I call a function here, in this case, I don't have like rules equals, like there's those hints in line. I hate those hints in line. It actually makes the code more complicated to read. Let's see. Okay, so now notice that all our tests are still passing, but we're still actually not calling it with the input. So now I can go ahead and say, well, now we can call and work with an input. Now, I'm going to stop here just for the demo, and I want to show you a few things that we covered. We've actually done a very, very incremental work, right? We started with something that was failing for, and then working for just a single rule, and now it's working for multiple rules. At every point of these tests, we could stop as every time the tests were passing, commit the code, and maybe even merge it to the master branch and actually give it to someone so they can maybe start using it or whatever. So that means that when we're doing TDD, it's a great way to work in an incremental fashion. And these are called micro iterations. And those micro iterations can take 2, 3, 5 minutes, 1 minute. So if every minute or a few minutes you're able to commit something, technically every few minutes you're able to merge something into the branch or do a pull request, which means you can do continuous integration of your code. That's continuous integration. Continuous integration is not continuous if you're only doing it once every couple of days. It's continuous if you're doing it continuously. And the smaller the batch size, the smaller the amount of work that you've merged, the easier it is to review, to test, to run the tests for, to do the merges if we need to do them manually for some reason. The code reviews are faster. Everything is faster and easier when you do smaller batches. Code fixes are easier. And that's part of the beauty of TDD. And I don't know if you've noticed, every time I did it, I always did something that feels like something is still missing, because I think that's one of the hardest parts in TDD, is to implement something in a simplistic way when I already know what is the generic way of solving it. I already know how I'm going to solve the whole thing. Why not just solve the whole thing, at once? There's a bunch of resources here, but now is the time where you can ask me questions about everything you've just seen, because I just showed you a couple of examples of how TDD works, and I want to hear from you if you have any questions about what we've just seen. Anything at all works. And I'm out of coffee. Many programmers would start with a simpler design with the rules as part of the very high pass and switch to an array at a much later stage. This is the notion of design. But I would argue that if you're starting with the test first and you already have notions of how to design things, the test can alert you to usability issues. But many programmers would start with a simpler design where the rules are hard-coded. This is a design issue, right? Technically, I could start with a rule and then extract it into a parameter array, and that's true too. And again, just making sure that all the tests are still passing, that works too. Any other questions? Answers? Let's see. Okay, so here's what I'm going to ask everyone: what kind of coffee you're drinking. I'm not allowed to say. Let's see. If you would like to get notified, I do a bunch of live streams here at this kind of here. Please register. I don't know why. Just register. What's going to happen? I want to see what happens. I want to see how many people I can have following there. I think the live streams are actually a good way to interact with people when we're all stuck at home. It's a much better way. Any questions? Any answers? Oh, yeah, okay. So if you want to do TDD katas, go to osherove.com, TDD kata, and then either do 1, 2, or 3. Thanks, man. Or woman. There's a bunch of katas in these URLs. There's a bunch of katas in these URLs. If you want books, TDD by example is great. This is like the original book that I read from Kent Beck. It's still good. Growing object-oriented software guided by tests. Definitely, if you're in the object-oriented world, this book will give you a glimpse of the way that Steve Freeman and Nat Price are thinking about that stuff, and they're really talking a lot about design, and they're using TDD in a design sense. There is, there's a thing called the London School versus the Chicago School of TDD. and the design is different between them, and that's okay. You should definitely learn about these things, and you'll figure out that sometimes this one is useful for you, and sometimes this one is useful for you, and then be done with it. The Art of Unit Testing, 3rd edition, is coming soon. The first few chapters are available for early access on the Menning website, so definitely go there. I'm also on Twitter. I don't know. Dumb question though. Can we use TDD for fuzzing kind of test? I guess. Actually, I've used TDD for various reasons. I've used TDD to see whether I can, for example, in legacy code, I use TDD to make sure that I actually understand the dependencies. Sometimes I'll actually just write a test without an assert in legacy code to see what's going to happen if I just try to new up an object. I call it wishful invocation. I'll invoke a function or invoke an object, and I'll just start seeing the trail of tears, the stack trace, and then I'll start refactoring the code a little bit until I can get rid of it, and then I'll actually write a real test. Cool. Any other questions before we finish for today? It's almost 1 a.m. here in Israel. How often do I commit? If I'm pairing, remember that there's local commit and there's remote push. Local commit, I might do 50 times a day. Now, when I pair with people, they might not feel comfortable with that because a lot of people don't realize the difference between a local commit and a push. Local commit is just saving things locally on your own GitHub Git repository, and then a push will take all of these commits. You can squash them if you want. I actually like the history of all these small commits. That wasn't a dumb question at all. Other questions? Answers. Can't definition of TD rely too much in unit testing, contrary to today, where people seems to do more functional testing. Well, I think that kind of brings us to this one. Where was it? Come on, this one. Maybe he was talking about unit testing. Maybe that's what worked for him. But again, I call these things ATDD, and these things I still call TDD. This is acceptance test. So this is more customer facing. You can write more customer facing tests here. So if you want to write stuff in Cucumber, you can still write stuff in Cucumber for these things. But for these things, you don't need to have a Cucumber test for these things, if that makes sense. Testing microservices. Testing microservices is actually sometimes is actually much simpler because microservices are very, very small. So they tend to have very defined APIs, and you can test them either out of process or directly as integration tests. And then you would have at least one end-to-end test that tests microservices connected to each other in a deployed system. So microservices have entry points and define entry points and exit points, which basically means it's very easy to test them usually. The only decision you have to make is whether you want to do it in an integration test with a real database or something like that, or with faking things. And I think that changes based on the type of system that you usually work on. Other questions? Or answers? Questions pretty valid. It's not a dumb question. Can we just say there are no dumb questions in this forum? If you have less experience, how are you going to find out if you don't ask? So sometimes I'll ask a silly question and I'll say, this might be a silly question, but... And I don't even care what everyone else thinks. I don't really care. The only times I care what other people think is if I'm a consultant, I'm going to a company, and I'm trying to make a first impression, and then I'll write down my questions for later, and then I'll find someone that I trust in that company, and I'll ask them some of those questions. But sometimes people will actually expect you to ask these questions, because then they'll trust you more, because they'll know that when you don't know something, you say you don't know it, instead of just telling everyone, yeah, I know everything. Sure. Ask and you'll be a fool for a minute. Don't ask and you'll be a fool forever. True. Yes. When working on a large system with many components, do you fake or stub your own components or use them anyway? It depends. It always depends. Let me see. This actually is a question of scope. If let's say I'm testing a component here, and I already have a bunch of logic written here. Do I use the real logic, or do I fake the logic? And the answer for me is usually I fake stuff that creates a dependency in my test. And a dependency is anything that makes my life more difficult. So for example, it could be something as simple as a regular expression that's very, very difficult as a dependency. Let's say that I'm testing a component that does verification on something, and there's a regular expression somewhere that verifies an input, and that input is very complicated, has to be complicated to match the regular expression. And to get to the code that I actually care about, I have to pass that regular expression check. I might fake just that small function and stub it out so that I will always pass the regex check. In fact, what you saw here in the example here in my code is that I consistently faked, or actually I stubbed out all the rules so that I'm testing the logic, but I didn't test a single rule yet, right? But now technically each rule can be tested separately. So yeah, so I'll stub things that represent complications, but if it doesn't complicate my tests, usually I'll try to work with the real object or the real function until I can't, or until it maybe is slow, or it introduces these kind of fuzzy issues, and then I'll get rid of it. But it really does change based on the code I'm working on. Have you worked with the blockchains in JS? If so, what are the architecture like in terms of frameworks? I know I've worked with blockchains, but not in the JavaScript sense, so I have no idea. So I haven't done that. But I have kind of touched on the world of Bitcoin, but not from the development side. Any other questions? We'll give it 11 more minutes and then I'm gonna go. Anything to do with unit testing, TDD, whatever. And if you're just tired as me, that's okay. You can just say I'm out. I guess that's it. Okay, so if you want to learn more, first of all, like and subscribe and click and smash and do the likes and all that stuff. But where are we? Where are we? Here, yeah. So if you want to learn more, if you want to contact me, you can always find me on Twitter. Oh, have you ever worked with? Yeah, no, it is. Find me on artofunittesting.com. Catch me on Twitter. Send me an email. Spam me. I don't care. And find out. Oh, and of course, don't forget. If you haven't been here when I said this, don't forget that I have this stuff. Register. All my courses on TDD are free for the COVID time, so you can enroll for free on my website and get all of the training in TDD and unit test and unit testing in Java and in C# and Ruby and all that good stuff. So feel free to just register. It's going to be yours for life once you register. That's cool. Have fun. May the force be with you. What else? Yeah, a few pointers for the design skill. A few pointers. What pointers can I give for design skill? That's a very generic question. There's a book called Clean Code by Uncle Bob that I really, really recommend if you want to learn that skill. It's really nice. Okay, thanks everybody. May the force be with you. I love you. Stay safe. stay at home, learn some stuff. Feel free to ask me questions. This is my email. Yeah, I guess that's it. Cheers, everybody. Love ya. Register for the Twitch thing and whatever is in the thing here.